Hi everyone, this is Mrs. V. Chen. Welcome to my Form 2 Math, lesson number 9. And today is 12 March 2020. Okay, so today's lesson is about deductive geometry. Okay, so the first one, we have axiom number 1. So actually what is meaning of axiom? Axiom is a statement or principle that is generally accepted to be true. Okay, so you look at this. If we are given the condition saying that POR is a straight line, so this is a straight line, therefore, we all agree with A plus B is equal to 180. Is that right? And therefore, we have this reference, which is same as before. We call that adjacent angles on straight line, right? Okay, now we come to the opposite to this condition. Okay, so this time, we are given this diagram, and then we are given the sum of this A and B is 180. So then what do you think? Then this line also must be a straight line. Is that right? So therefore, here we have the reference, which is opposite to adjacent angles on straight line. That will be adjacent angles, and this is supplementary, and the short form is SUPP dots. Alright, so this is the opposite to adjacent angles on straight line because the condition given to us is opposite to this axiom, to this statement. Okay, so next, we are given this AB and CD, they are parallel. Okay, so if these two lines are parallel, that means we all agree that angle A and angle B must be the same. Okay, so what is the reference to this? This is corresponding CORR dots, angles, comma, because AB being parallel to CD. Alright, so this is what we have before. However, if you look at this, the condition given to us is just the opposites. Now this time we don't know whether AB parallel to CD, we don't know. But however, we are given this angle is same as this angle. So our conclusion can be AB must be parallel to CD. So you can see this is exactly opposite to this. Therefore, what is the reference? The reference here is corresponding CORR dots, angles equal. Okay, to say that we have two parallel lines. If this angle is equal to this angle, so which is corresponding angles equal. And this is opposite to corresponding angles because AB is parallel to CD. Okay, next, again here, we have two parallel lines given to us. And then we all agree that angle A and B here must be the same. Okay, so what is the reference here? Which is alternate angles because AB parallel to CD, right? We all agree with this, right? Okay, but now in this diagram, we don't know whether AB is parallel to CD. However, we are given this angle A is equal to B. Then our conclusion saying that AB must be parallel to CD. So you can see this condition is exactly opposite to this, and the reference will be alternate ALT dots, angles equal. Okay. All right. So finally, we have this one. So AB parallel to CD. Therefore, we all agree with this statement, which is A plus B is equal to 180. Agree? So what is the reference? The reference here is interior angles AB, which is parallel to CD. Okay, so we have proved this before, and we all agree with this as well, right? And the opposite, we don't know whether these two lines are parallel. But since A plus B is equal to 180, so we can make our conclusion that these two lines must be parallel. Again, this one is opposite to this. So therefore, we have the reference, which is interior dots, angles, supplementary, S-U-P-P dots. Okay, so this is the major thing in this chapter that we are going to prove. Use all these references. Okay, next, let's practice by looking at these examples. Okay, here is the diagram. Okay, and then AOD is a straight line. So here we have a straight line. And also, we are given this if BO, which is parallel to OC, that means this angle is a right angle. Is that right? And now what do we need to prove? We need to prove that x plus y is equal to 90. Okay, so are you ready? So therefore, we start with this x. So x plus 90. So you can name it or you can name it later. So angle BOC plus y is equal to 180. Okay, so which reference do we use here? And then we are given this, which is a straight line. So that will be adjacent angles on straight line, right? And what is angle this BOC, which is given to us? So which is equal to 90. So I just do substitution. Okay, now x and y is the subject. So I always put subject on the left hand side. Now I move this to the right hand side. So that will be 180 minus 90. Okay, which is equal to 90. So x plus y is equal to 90. Okay, so this is it. And this is how we prove the condition here by using adjacent angles on straight line. Okay. Okay, let's look at the next example here. Example 2. So we have this is x, this is 90, y, 90, y, and x. And now we need to prove that AOD is a straight line. Okay, that means we don't know yet this is a straight line. Okay, let me remind you. So can you say that x plus 90 plus y is equal to 180? No, you cannot do that because we don't know this is a straight line. So therefore, we have to look at the whole thing here. All right, so what do you think about the total of this? If I start from here, so this is x plus 90 plus y plus 90 plus y plus x is equal to 360. Okay, so the reference is angles at a point, right? Okay, next, let's simplify. So x and x, so I have 2x plus, and then I have 2y equals to this 360 minus 90 minus 90. Okay, so next I have 2x plus 2y, which is equal to 360 minus this, so which is 180. Okay, so 2 and 2, which is the common factor. So therefore, I have x plus y inside the brackets, which is equal to 180. Okay, so therefore, what is x plus y? That will be equal to 90. Okay, so therefore, I need to use this later. Okay, so after that, so this is x. I'm going to work out the sum here and say angle AOB plus angle BOC plus angle, so this is COD. Okay, next I want to work out the value for this. Okay, I don't know yet. And then this is x, this is 90, this is y. Is that right? Okay, and then I move these two together, so x plus y plus 90. Okay, so what do you think about the value? Since we work out that x plus y is equal to 90 before, so I can change this to 90 plus 90. Okay, so what is it? This is 180. Right, so if all this angle, the sum, is equal to 180, then what is our conclusion? We can say that AOD is a straight line. Okay, so what is the reference to this? The reference is opposite to adjacent angles on straight lines. So that would be ADJ dots angles SUPP dots, which is exactly opposite to example 1. So here, okay, the reference is adjacent angles supplementary, which is opposite to adjacent angles on straight line. Now be careful, so we have to make sure and work out the sum of these 3 angles is equal to 180. If the total of them is equal to 180, then we say that this must be AOD must be a straight line. Okay, so which is just opposite to example 1. Okay, the condition is exactly the opposite to condition to example 1. All right, example 3. Here is the diagram. Okay, and part A, we need to prove that AB here is parallel to DE. Okay, so therefore, I'm going to link up this angle, and this angle. Okay, this angle, let's name it. So this is angle CDE plus this angle, which is DEC, same as this angle. Okay, so this is angle BCE. Okay, remember, this is a triangle, and this is outside the triangle, and the sum is this. So which reference is that? So which is EXT dots, exterior angle of triangle, right? So now this is my subject here. So angle CDE plus this x plus 8 equals to 2x plus 8. So therefore, I need to change subjects. CDE is my subject, and work out that in terms of x. So therefore, this is 2x plus 8 and then minus x and minus 8. I move this to the right hand side. Okay, so therefore what is angle CDE? That will be 2x minus x. So 2x minus x, which is x, and then no more. So therefore you can see CDE is also same as x. Okay, so if this is x, this is also x. So we can say that this is also same as angle ABC. Is that right? So since these two angles are the same, so we can make our conclusion that's and saying AB must be parallel to DE. Okay, what is reference? This is opposite to alternate angles parallel. So what is opposite to that? That would be alternate angles equal. Okay, so this is how we prove AB being parallel to DE, because this angle is x, this is also x, so we say that these two lines must be parallel, and the reference is alternate angle equal, and here we use exterior angle of triangle as well. Okay, now part B of example 3, the same diagram. So we are given this. If ADC, sorry, it's ADC, ADC is here, which is same as CDE. So CDE, therefore if this is x, then this is also x. Is that right? And also we are given BAD. So where's BAD? BAD. So the big one here is 100. Okay, now we have to find angle BCE. So I have to find the value of 2x plus 8. Okay. All right, remember just now we already proved that AB parallel to DE, so this is parallel. Okay, so I start from here. So AB, which is parallel to DE, and we have proved that. Okay, so therefore, can we join these two angles together? So that would be angle BAD plus, okay, this big angle, so angle ADE is equal to 180, because these two parallel lines, we already proved that, which is interior angles, comma, because AB parallel to DE, right? Okay, and what is this BAD, which is 100 plus 2x equals to 180. So therefore 2x. 2x is equal to 180 minus 100. So that is 80 left. Okay, so x is equal to 40. Okay, and we have to find angle BC. So there, angle BCE, according to the diagram here, BCE is same as 2x plus 8. And just now we work out 1x is 40, so that would be 2 times 40 plus 8. Okay, so what is it? So this is 80. 80 plus 8, which is 88. So therefore the value for this angle, which is equal to 88. And what is the reference we used here? The reference we use here is interior angles, because AB parallel to DE in part B. And then we prove these two parallel lines being equal in part A, and then we use this alternate angle equal. Alright? Alright, so now example 4. This is the condition. Given AB parallel to CD. So we have these two parallel lines. And now we need to prove P plus Q is equal to R. Okay, so to do this question, we need to add another line here, crossing. Okay, and which is also parallel. So name it. Let's say this is P, this is Q. Okay, so you have to name it. So add line PQ, which is parallel to AB. Okay, so if it is parallel to AB, therefore it must be parallel to CD as well. Okay, so therefore let's look at R here. We have to break down R into this one and this one. Okay, and what do you think about this angle? Okay, so angle AEP, all right, is equal to P. All right, so this angle is equal to this angle. Okay, so which reference we use that, which is alternate angles, comma, because AB parallel to PQ, right? So I know this one is also same as P. Okay, next, this one is parallel to this. So I can say that this part, this little one, angle PEC is same as Q here, right? So the reason is also alternate angles, because PQ parallel to CD, right? Okay, now almost done. R actually is the total of angle AEP plus angle PEC. Therefore, R is equal to, what is AEP? Just now we work out that as P, and this is Q. Okay, so therefore, this is it for example 4. In this question, we need to add another line which is parallel to AB and CD. Okay, now we come to the final example in this chapter. So here is the diagram. Okay, and then now we have to find X. So X is here. Okay, so I'm going to look at this inside interior. So this. So how many of them? Let's count. 1, 2, 3, 4, 5. So actually this is a pentagon. All right, so that I have to work out this angle first. Okay, and this angle is angle PTS. Okay, plus 30 plus 125 plus 105 plus 50 is equal to, remember, what is it? A pentagon. How many sides are there? We have 5 minus 2 times 180. So what is the reference I used here? Which is angle sum of polygon. Remember that? So therefore, I need to find my subject here. Angle PTS is equal to, so where's my calculator? Okay, so sum of pentagon, so 3 times 180, so 540, and then move this all to the right hand side, minus minus, so therefore I get this angle as 540 minus 30 minus 125 minus 105 minus 50, so that this angle is equal to 230, right? Okay, now x is here. So what do you think about x? X plus my angle here, angle PTS, is equal to 360. Okay, what is the reference? Which is angles at a point, right? And substitute x plus 230, which is 360. Therefore, what is x? So 360 minus 230. So the answer is 130. So this is how we work out part A to find x. So let's take a look at the references I have used here. I have used this angle sum of polygon, and then there is angles at the points. Okay, and this is part A. Okay, now part B of example 5, the same diagram. The condition is this. So angle TPS, so this is TPS, so this angle and this angle TSP are the same. So you can see this is an isosceles triangle. So can I let this be y, for example? Okay, so if this is y, then this is also y. Is that right? Okay, so therefore in triangle PTS, so I can have this angle TPS plus angle TSP plus x here is equal to 180. Okay, what is the reference? Which is angle sum of triangle. Alright, so this is y plus x. What is x just now in part A? Which is 130 equals to 180. So I have 2y equals to, you move this to the right hand side, 180 minus 130, which is 50. Okay, 2y is 50, then 1y is 25. Okay, so this is 25, so therefore this is 25. Okay, now what is the thing that we have to do here? We need to prove that PS is parallel to QR. Therefore, okay, look at these two angles. I want to know what is sum of these two angles. So this angle is SPQ plus this angle PQR. Okay, I don't know the value yet. I have to work out that. So what is SPQ? So this is SPQ, which is equal to y plus 30 plus. Okay, what is this PQR? Given 125. Okay, and what about y? Y is same as 25, so I replace that to 25. Okay, so therefore 25 plus 30 plus 125 is equal to 180. Oh, look at that. This angle and this angle, the total is 180. Now can we make our conclusion that saying PS is parallel to PQ? Yes, of course. So therefore PS must be the same as QR, and the reference is just opposite to interior angles. So the reference will be opposite to that. That will be interior, INT dots, angles, SUPP dots. Okay, so be careful when you prove this and using the opposites. You have to work out the value, all right, to say that they are parallel to each other. So I have used this reference, opposite to interior angles, parallel line. Okay, and then also I have used angle sum of triangle. Okay, so this is all about chapter 9, deductive geometry. So thank you for watching my video. I'll see you next time. Bye bye.